In this video, we're going to use the trig ratios that we learned about in the last video to help us solve for an unknown side length. It's really kind of cool actually now that we can use all this trig that we've been building up, all these opposites and adjacents and hypotenuses and thetas, and start to do some pretty straightforward problem solving. The most difficult part of this is going to be making the decision on which trig ratio we're going to use. So we have to decide whether these problems involve sine, cosine, or tangent, and we're going to use them to find the unknown side length. We will be looking for angle sizes in the next video, but for now we just want to use our calculator and our knowledge about these angles and side lengths in order to solve for a missing side length. So let's take a look at the first example. Right, and what I'm going to do is I'm just going to do a quick little note for myself here where I'm going to use SOHCAHTOA. This is why we worked on that acronym in the last lesson. So SOHCAHTOA, remember, stands for sine is our opposite over our hypotenuse, cosine is our adjacent over our hypotenuse, and tangent is our opposite over our adjacent. So we're going to use SOHCAHTOA to help us decide which ratio that we need to use to solve for x. We're looking for side x here. Okay, we can actually also call x, we can also call it little c. Okay, so I don't recall if we did this in a previous video or not, but it certainly is not terrible to go over it again. If we have triangle A, B, C, then we usually name our angles with capital letters and our side lengths with lowercase letters. And the side lengths get named after the angle that they're across. So angle A is right here, so the side opposite it is little a. Okay, and angle B happens to be our right angle triangle, and across from little b or across from angle B is little b, and then across from angle C is little c. Okay, and they might be the opposites or the adjacents or the hypotenuses or whatever, but we can also call them by these lowercase side lengths, or we can call it by a variable like x. So you're going to see a couple of different ways that these are presented to you. And I don't want you to get freaked out by any of them. They're all kind of asking the same thing, right? We want to get used to as many kind of formats and acceptable uses of variables that there are. All right, so let's go back to this example. How are we going to figure out x? How are we going to figure out x? Well, let's look at the angle that we're given. We're given 55 degrees is angle C here, right? And we also are given this side length here. We're given a little a, right? Because it's across from angle A. So we're given a little a equals 15 centimeters. So relative to that 55 degrees, little a is actually the adjacent. And we're looking for x, which is opposite of this 55 degree angle. So when we have relative to this 55, when we have the adjacent and the opposite, which of these three ratios is that involved? Which one has the opposite and the adjacent in it? Oh, that's tan. We're going to use tan. Okay, so we're going to use tan. All right, so 3 steps, always 3 steps. Whenever you're solving anything that has a formula for me in math or in science class or any, Miss Mason or Mr. Sadler, they're all going to expect the same thing. So we start by writing our structure. Tan theta is opposite over adjacent. Okay, so that's going to get you a mark because that shows that you selected the correct ratio for this problem. And in grade 10, this is a new concept, so you get the mark for saying, hey, wait a minute, I got to use tan for this, and this is what tan looks like. Please do not forget that angle size. Those are supposed to be exclamation marks. Those are so important. It's so important that you include that angle size there. Never say tan equals, right? We always say tan theta or tan C, okay? But we're going to start with this. So the ratio, tan ratio, is always opposite over adjacent, and then we fill in what we know. So we know in this case theta is 55. Tan of 55 degrees equals our opposite, which in this case is x. X is given to us in the problem, so we want to use x in our answer, over the adjacent, which is 15. Okay, now remember, we're solving for x. Since we're solving for x, we need to get x by itself. And currently, x is being divided by 15. So what I want to do is I want to multiply both sides of this equation by 15 and get x by itself. Okay, so we got to do a little bit of algebra here. In this case, it's only one-step algebra. So if you can go straight to the answer, but I encourage you to kind of show this next step also. X equals tan 55 times 15. Okay, and that'll help you see what you have to put in your calculator also. All right, here's my calculator. Make sure I'm in degree mode, so important. And I'm going to press tan 55. My calculator opens a bracket for me because I can actually multiply a bunch of stuff and take the tan of it, but I don't want to do that. In this case, I only want to take the tan of 55. So for my calculator, I need to close the bracket. Again, in some of your calculators, you're going to press tan, or you're going to press 55 and then tan. Okay, and you'll get something like 1.42814, blah, 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 blah. Okay, so if you see that number pop up, that's the tan ratio for 55 degrees. So for me, the way my calculator works, tan 55, and then I'm just going to close my bracket, times 15. So if I get the 1.48 blah, 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 it means I didn't multiply by 15. I'm still at tan 55. So I should get x equals 21.42, and we're measuring in centimeters. So I need to have centimeters in my answer. Okay, so I promise this is going to be really easy once you figure out how your calculator works. And it's really important that you play around with this and kind of keep track of the steps that you're using in order to get this 21.42. If you have to, go to Google and put your you can always go to Google and put your brand of calculator in and ask and then get some hints on how to use your calculator for trig, and it will kind of show you a video. You'll be able to find one really easy. If you have to, give me a call. We'll take a look at your calculator and we'll see how we can get this to work. Because as soon as you're able to get this 21.42, you are off to the races and everything's going to be great. And you'll get 2 out of 2 on this guy. Okay, so play around with it until you're able to get that answer. All right, let's take a look at the next example. Let's find the length of side C. Now in this problem, it's not labeled for you, right? But we know that side C is across from angle C. So that's what we're looking for. So what trig ratio are we going to use here? Pause video. Okay, think about what information do we have? We're given this 50 degrees, and the side that we're looking for is opposite of the 50 degrees. So that's my opposite of my indicated angle. And the other side that I'm given is this 5.2. And the 5.2 just happens to be across from the 90 degrees. So that's my hypotenuse. So look back at our SOHCAHTOA. Which ratio uses opposite and hypotenuse? And it's sine, right? Opposite and hypotenuse is sine. So we set up our sine ratio. Sine theta equals opposite over hypotenuse. And we plug in what we know. We know theta is 50 degrees. So sine of 50 degrees equals my opposite. That's what I don't know. So I'm going to call that little c in this case. Over my hypotenuse, which is 5.2. Okay, and again, we're solving for c, and c is being divided by 5.2. So to get c by itself, we're going to multiply both sides of this equation by 5.2. And we put that in our calculator. Sine 50 times 5.2 equals c equals 3.9834 31104, right? Or we can just write 3.98 centimeters. You can include all of the decimal places if you like. If you're going to use less decimal places, don't round until you're completely done all of calculation here, and we can round it to 2 decimal places. 3.98 is perfect. The other thing I want you to think about is I want you to think about how reasonable that answer is. Okay, well, it got a little blurry here. Let's try to fix that up. There we go. Okay, remember that the hypotenuse is always the longest length of any right angle triangle. So if the hypotenuse is 5.2 and the opposite here is 3.98, that's a really reasonable answer, right? This is about 4, just less than 5. That's really, really, really reasonable. We probably should have some units. Okay, same with this first question here. How reasonable is 21.42 centimeters here? Well, is it in the ballpark with 15 centimeters? Absolutely. And what I mean by that is we didn't get something crazy in our calculator. If we had done something silly like 15 divided by 1055, we divided instead of multiplying. Well, 10's pretty reasonable too, but 21 is nice in nice ballpark. 10's kind of rough because 10's rough to give us reasonable answers, but this 21.42 is in the ballpark of these guys, right? It's not 214, it's 21. Okay, so that's a nice reasonable answer. And we want to check that because for this final question down here, a lot of students mix up the algebra that they need to solve for side F here, because side F, you'll notice, is our hypotenuse. Okay, so relative to 55 degrees, 6.8 is our opposite, right? And we're looking for F, and F is our hypotenuse. So which of our 3 ratios, when we go back here to the top, which of our 3 ratios use opposite and hypotenuse? Oh, it's sine again. And it's okay that we don't have a cosine in our notes because it's exactly the same. The steps are completely the same. You're just going to use cos instead of sine, okay? But in this case, we're using sine again. So let's write sine theta equals opposite over hypotenuse one more time. And theta is 55 degrees. And our opposite in this case is 6.8, and our hypotenuse is little f. That's what we're looking for. Well, I know that you did this algebra last year. I beg Mr. Neufeld every year to make sure he goes over how to solve for a variable when it's in the denominator of a fraction. So you're going to have to dig a little deep in the brain to figure this out if it's not obvious. But I'm going to show you a shortcut. And it's kind of based on this idea, right? And I can show you the algebra too, but I really want you to think about what's 10 divided by 5? Well, 10 divided by 5 is 2, right? Obviously, that's an easy question. So what's 10 divided by 2? Well, 10 divided by 2 is 5. That's because 2 and 5 are factors of 10. And that means we can interchange them, right, and get the other answer. So what we can do here is we can actually interchange that f and that sine 55. And we can say f equals 6.8, which is kind of like the 10 right here, divided by sine 55. All right, now why does that work? You know, Miss Glendy doesn't like to show you tricks. So what's the thinking behind that? Well, I really like this conceptual understanding of factors. It's just really hard to think about sine 55 as being a factor of a number. So think about this instead. I'm going to put a nice big thought bubble here. So you don't have to write it, but you can think about it. I'm going to multiply both of these sides by f, because right now 6.8 is being divided by f. So I'm going to multiply both sides by f. So I have sine 55 times f equals 6.8. And then now I want to get f by itself, so I'm going to divide by sine 55. I do that to both sides, right, to maintain balance. These guys cancel, because sine 55 divided by sine 55 is 1. And f is left to be 6.8 divided by sine 55. And I just personally don't like to do 2 extra steps of algebra if I don't have to. So I go back and I think about this kind of property of numbers over here, right? And then I can see that I can just switch these two guys around. Okay. We only have to do that when f, or the unknown, is in the denominator. Notice we didn't do any switching of anything up in the previous examples, but these ones are really the hardest questions we have to answer in this unit, so you're going to be fine. Okay, f then is going to be 6.8 divided by sine 55, which in this case, little f equals 8.30126724, or we can just say f equals 8.30, and that's in centimeters also. Okay, does that make sense? Is 8.30 a reasonable answer? And it absolutely is. The opposite side is about 7, and the hypotenuse has to be longer, and it's 8.3, which is really reasonable, right? That's a very reasonable answer. If I had mucked this up and I had done, I don't know, let's say I multiplied. Like I did in the last two examples. Instead of dividing, if I multiplied sine 55 times 6.8, I would get 5, right? If I multiplied instead of dividing, I would get 5.57 for my hypotenuse. Now it's in the ballpark, but remember the hypotenuse is supposed to be the longest length, so it doesn't actually make sense. So I know that multiplying those two numbers would have been a mistake, right? And I'd have to divide them instead. Okay, so I really encourage you to do a bunch of independent practice. Trig is a really helpful skill. We do trig in every grade in math, in all 3 maths. So we do trig in essentials, in pre-cal, and in applied. So this is really a basis for lots and lots and lots of units of math to come, no matter what math class you take.